How to use the quotient rule to differentiate. For this question, we need to find and simplify dy dx. Looking at the rule of y, because we have a division of two functions that can't be simplified any further, we need to use the quotient rule to find its derivative, which is going to be this formula. And so what we do is we let the top function equal u, and so this is going to be 5 minus x squared. Deriving this, we're going to get minus 2x. The bottom function is going to be v, and this is e to the x. Deriving this is going to be e to the x. And now we just sub these into the formula, and so we're going to get dy dx is equal to v times u dash, and so this is going to be the same as 2x times e to the x, and then minus u times v dash, and so this is going to be 5 minus x squared times e to the x, and then all over v squared, which is going to be e to the x all squared. We've got e to the x in each term and in the denominator, and so these are going to cancel out. And so simplifying this is going to be minus 2x minus 5 plus x squared all over e to the x, which can also be written as x squared minus 2x minus 5 all over e to the x. Now that you know how to answer this, you should be able to answer this quotient rule exam question from the 2023 Maths Methods Exam 1 paper, which was worth 2 marks. Give it a go. And if you want to practice more questions similar to this one, then log into the Maths Methods Club. And from the main topic, select differentiation. And then from the subtopics, select chain, product, and quotient rule. Then go down to exam number, select exam 1, and then click on filter. This is then going to instantly group all the past Maths Methods exam questions from the exam 1 paper, asking you to find the derivative using the chain, product, or quotient rule. Try out all of these questions, as exam 1 paper always starts with a differentiation question. After going through these videos and learning how to answer each one, you're going to be ready for your Saxon exams when it comes to differentiating functions.